Okay, so before I solve an absolute value inequality problem, let's consider a very simple one. The absolute value of x is less than 3. If I graph y equals the absolute value of x, we get this V-shaped curve, this graph. This is the graph of y equals the absolute value of x. If I also graph y equals 3, well, the graph of y equals 3 is a horizontal line going through y equals 3. Notice the graph of y equals the absolute value of x. That's this graph right here. When is that graph below less than? When is it below 3? Well, this x value is negative 3. This x value is positive 3. The part of the graph that is below less than 3, the graph is less than 3 when we're between negative 3 and positive 3. Yeah? So what do we do here? All we could do to solve an absolute value inequality is drop the absolute value, repeat the inequality symbol, repeat that number there. Then all you do is just put the opposite of this number down here, and then we're solving a compound inequality, which we learned earlier. So let's use that right here. So the absolute value is less than 6. Drop the absolute value. Repeat the inequality, make the same sign, and then the opposite of 6 is negative 6, and now we just solve this compound inequality. Add 4 to all three parts, the left, right, and middle. Negative 6 plus 4 is negative 2. Negative 4 plus 4 is 0, that leaves us with 2x. 6 plus 4 is 10. Now we divide by 2. We do not need to worry about reversing the inequality. Remember, we only reverse it when we multiply or divide by a negative. So we don't reverse it. This cancels, we get x. Negative 2 over 2 is negative 1. 10 over 2 is 5. So this is the solution to this absolute value inequality. Just as a refresher, let's write this using interval notation. In interval notation, this is saying x, it's all the numbers between negative 1 and 5. Parentheses around 1 and 5 because there's no equal. We use parentheses. So that is the solution using interval notation. That's the solution if we use inequality notation.